Alright, this is part 2 of our video reviewing our unit on polynomials and exponential expressions and radical expressions. We've already done all of these problems 1 through 8. So with this video we will pick up with number 9, where we are about to simplify, if possible, these exponential expressions, and then we will rewrite the exponential expressions as radicals. Alright, look at number 9. There's a couple different ways we can look at this. One way is, look, we have this 8 and this x inside the parentheses, and we are raising this 8x to the 1/3 power. So one way you can look at it is we're taking each one of these and we're doing it to the 1/3 power. Now, either way you go, we have to rewrite this as a radical. That's our ultimate goal anyway. And plus it helps us to remember that 1/3 power means the same thing as the cube root. So remember, n to the 1/3 power is the same thing as cube root of n. You know what I mean? N to the 1/4 power, that's the 4th root of n. And for example, n to the 1/2 power is the square root of n. Don't put the 2. So with this in mind, we know that 1/3 power, that's just the cube root. So what we really have here is the cube root of each of these things. Okay, so we have the cube root of 8 and we have the cube root of x. Now this is convenient because 8 is a perfect cube. Alright, remember, it's another thing to keep in mind. So many side notes. Where do we begin? Perfect cubes. I'm going to list a few. If you have 1 to the 3rd power, of course that's 1. But 2 to the 3rd power is 8. 3 to the 3rd power is 27. And if you ever needed more perfect cubes, you could get them off your calculator, yes? Okay, for example, 4 to the 3rd power is 64. I'll do one more. 5 to the 3rd power is 125. So you can always generate this list anytime you want. Or maybe when you first get a test or a quiz, just write these in the margin. So anyway, we said 4 to the 3rd power is 64. 5 to the 3rd power is 125. Now, why am I writing these down? I need you to just remind you about how the cube root works. If I asked you, what is the cube root of 64? What would you say? Well, hopefully you would say that's 4. Because you see the 64 right here. The cube root is uncubing this and taking it back to 4. Okay, so here's another quiz. What is the cube root of 27? Say it out loud. It's 3. You see the 27. So if you have this list, it makes it easy because you can just look back and see where it came from. Okay, and so that's why, coming back to the problem, if I have the cube root of 8, what's that? The cube root of 8 is 2. Alright, because there's 8. The cube root is uncubing the 2. And then the cube root of x, there's nothing we can do about that. So this is simplified and written in radical form. 2 cube roots of x. Plus a lot of background, extra information for you. So number 10. Got to clean up a little bit around here. Who left this mess? So number 10. So I see I got this 2 here and stuff. So I've got 2, and then I've got this power to a power. Okay. Remember, when you raise a power to a power, you multiply. So this is like 2, and then I've got y to the 4th power, but it's times 1/6, okay? 4 times 1/6, power to a power. Now, the way you multiply with fractions is, first of all, this 4 is just like 4 over 1. So you just multiply straight across. 4 times 1 is 4, 1 times 6 is 6. Okay, so this is going to become 2y to the 4/6 power. Just multiply it straight across. Of course, this will reduce 4 over 6. If you divide both of these by 2, and I'll just show it to be thorough. Okay, divide by 2, divide by 2. Alright, then we have 2y to the 2/3 power. Now, there are no parentheses or anything, so I need you to understand that unless there's a parentheses reaching out and including the 2, the exponent only applies to the thing that it's touching. Alright, so this is y to the 2/3 power. It's not 2y to the 2/3 power. That's important because I still have to rewrite this as a radical. Okay, so when I do this, and let me just recopy, it's like I have 2 and then I have y to the 2/3 power. Okay, the y part is separate. So when I do this, remember what we're looking at is power over root. So that means I have the cube root then. Alright, so I have the cube root of y squared because 2 was the power. Okay, and then this 2, just bring it down. Doesn't really do anything. So really that 2 didn't do anything throughout the entire problem. You just brought it down, brought it down, brought it down. It just stayed in front. Didn't get involved. Okay, so that's how you do number 10. Number 11. Well, I'll tell you what. Anytime I see a negative exponent, the first, I'll repeat, first thing I do is I move it. I like to move it, move it. So this, because it has a negative power, is going to travel to the other side of the fraction. It's going to join the 2 in the numerator. So on the next step, this is going to become, alright, so remember I had a fraction like this, right? The 2 was up there just chilling. Now this x comes up and becomes x to the positive 2/3 power. Now since there's nothing here in the bottom, I don't need to put anything. So far I just have this 2x to the 2/3 power. But we are supposed to write this as a radical. So like I mentioned on the last problem, since there are no parentheses around the 2 and the x, this 2/3 power only applies to the x. Okay, so that 2 is going to sit there minding its own business. Nothing's going to happen to it. But meanwhile, this is going to convert. This is the power, and this is the root. Okay, so the root is 3. So once again, I've got that cube root. And then I've got x squared. Okay, because that's the power. And that is all she wrote. Okay, good jobby job. Alright, for number 12, we switch gears. We're still simplifying, but then we need to rewrite as a rational exponent. That means like with fractions, no radicals. All exponents should be positive. Okay, that's a given. Now, I feel like I'm seeing something new that we really haven't talked about before, so we need to talk about that. Okay, when you look at the cube root of 27 x to the 4th power, I'm hoping you're noticing right away that 27 is a perfect cube. Remember, because 2 to the 3rd power is 8, 3 to the 3rd power is 27, see, and I'll just put one more, 4 to the 3rd power is 64, and so on. These are all perfect cubes. Okay, so remember that the way perfect cubes work is that if I take the cube root of 8, that's 2. If I take the cube root of 27, that's 3. If I took the cube root of 64, that's 4. Okay, so the cube root just uncubes you. It takes you back to the number before it was cubed. Okay, that's what the cube root does. So when I see this 27, and I see that I've got the cube root of 27 right here, okay, just like this, I'm hoping it starts to jump out at you that that's just going to be 3. Alright, so it's just a matter of how do we separate it from the x to the 4th power. And here's how we do that. Yeah, just understand this. If you take the radical of two things, like say if I have the cube root of np, just understand that that's the same thing as the cube root of n and the cube root of p separately. Okay, you can basically just split it up and have the cube root of both sides. Okay, to split it up into 2 cube roots, and it's the same thing. Okay, so how does that apply to this problem? The cube root of 27 x to the 4th power is the same thing as the cube root of 27 times the cube root of x to the 4th power. Just split it apart. Now, the cube root of 27, like I said, is 3. Okay, so this is just going to become a big old 3 outside the radical. Now, as far as the cube root of x to the 4th power, well, it's time to go ahead and rewrite this as a rational exponent. That means a fraction. Okay, so no radicals. We're writing it in exponent form. And remember, when we do exponent form, we do power over root. Okay, 4 is the power, 3 is the root. So I'm going to have x to the 4/3 power. Power over root, 4 over 3. And that's it, ladies and gentlemen, for number 12. Okay, we simplified and we wrote it in rational exponent form. Okay, I'm just going to clear this mess out for a second. Okay, now looking at number 13. Let's see. We'll just do the same thing. So this is the same thing as the square root of 5 and the square root of x. But I hope you remember that the square root is the same thing as the 1/2 power. Okay, so this is the same thing as 5 to the 1/2 power, x to the 1/2 power. Okay, kabam. Number 14. Well, that -7 out front is just going to be sitting there for a while. But the cube root, 24 is not a perfect cube. Okay, and also the calculator won't help us. But again, the first few perfect cubes are 2 to the 3rd power, so 8 is a perfect cube. 3 to the 3rd power, so 27 is a perfect cube. That's already too big to divide evenly into 24. So it's 8 or nothing. It's the only thing we got as far as a perfect cube. Does 8 go evenly into 24? Well, hopefully you know your multiplication facts. And if you do, you know that 24 is 8 times 3. So I have my -7, so I'm just bringing that down. Now this cube root of 24 can split apart as the cube root of 8 times 3. Alright, I'm just splitting the 24 up into 8 times 3. Now I put the 8 in red to show that it's about to be simplified. Okay, how do you do the cube root of 8? Well, remember, the cube root just takes you back to where you came from. Alright, so the cube root of 8 is going to be 2. So this cube root of 8 is going to come outside of the radical and become a 2. Everything in blue is going to stay what it is. So I'm still going to have a negative 7 out here. It's going to wind up multiplying. And I still have the cube root of 3. It's just imagine I'm erasing the 8. So I still have my cube root of 3. Alright, the 8 just gets simplified. Now, these will multiply together and make negative 14. And this will not simplify anymore, so we might as well make it the exponent that we were asked for. So remember, cube root is the same thing as the 1/3 power. So I have negative 14 and then times 3 to the 1/3 power. Alright, that's enough for this video. So I'm going to stop this video here, and we will pick up on the next video with number 15, where we will be simplifying radical expressions.